This is the study guide for solving one-step equations for adding and subtracting. So when we solve one-step equations, we want to use inverse operations, and those are operations that are the opposite of each other or they undo each other. So addition is the opposite of subtraction. Subtraction is the opposite of addition. And then in the next recording, we'll talk about how multiplication is the opposite of division and division is the opposite of multiplication. So for the addition property of equality, if you add the same value or the same number to both sides of an equation, the result is an equivalent equation or equal equation. And then if you subtract the same value from both sides, the result is an equivalent equation. So as long as you do the same thing to both sides of the equation stays equivalent or equal to each other on both sides. So if you look at this example, you've got x plus 23 equals 90. And so we want to know what x is equal to. So what we do is we subtract 23 from both sides and we get x equals 67. So since we had addition, we did the inverse operation, which was subtraction, and we subtracted 23 from both sides to cancel out the 23 on this side and then to have the answer for x on the other side, which is 67. And then for the second example, we had subtraction, x minus 12 equals 74. So the inverse operation of subtraction is addition, so we added 12 to both sides to get that x is equal to 86. And what you could do to check your answer for both of these is you could plug back in the number for x. So for example, for the first one, I could plug back in 67 and 67 plus 23 and see if that equals 90. So I could check that. And 7 plus 3 is 10. And then 1 plus 6 plus 2 is 9. So that's right. I got x is 67. And when I plugged it back in for x, I still got the answer of 90. And then the same thing for the subtraction one. If I do 86 minus 12, I should get 74. So I could try that out. And 6 minus 2 is 4, and then 8 minus 1 is 7, so that one is also right. So when we put back in the number for x, that is called substituting, and that just helps us check our answer. So when we solve equations, sometimes you'll hear it called balancing the equation. So again, we just do the same thing to both sides. So if you look at this example, you start off with x plus 2 equals 7. And on one side of the scale, you have x plus 2 of those little blue circles. And on the other side of the scale, you have 7 blue circles. So they took off 2 blue circles on each side, and they were left with x on one side. And then on the other side, they were left with 5 blue circles. So we know that x would be equal to 5. So when we want to get the variable, which is the letter like x by itself, that's called isolating the variable. So getting it all alone and all isolated is what you want to do to solve equations. So we do the opposite operation or the inverse operation of what is shown. So if we have addition, we would do subtraction. If we have subtraction, we would do addition. And then when we do the same thing to each side of the equation, we're balancing the equation, just like this example with the scale. So here is another example. We have x minus 4 equals 7. So we have subtraction. So we want to remove the minus 4. And so we do the opposite, which is adding. So we do the inverse operation of subtraction, which is addition. And then we cancel out the minus 4 plus 4 because, like this says here, negative 4 plus 4 is equal to 0. So that's why they cancel out. So then x is left by itself, and then on the other side we do 7 plus 4, which is 11, and then we substitute back in our number for x, so we put in 11 for x, and 11 minus 4 is 7. So now if you want to pause the recording, you can try out these independent practice problems, and I will go through them after you finish solving them. All right, so for this first one, we have y plus 14 equals 29. So when I have addition, I do the inverse operation, which is subtraction. And I subtract, I'm going to write it a little bit bigger over here. I subtract 14 from both sides. So I have y plus 14 equals 29. So I would subtract 14. So positive 14 and negative 14, they cancel out. Then I'm left with y equals, and then 9 minus 4 is 5, and 2 minus 1 is 1. So for this first one, y is equal to 15. For this next one, I have subtraction. So when I have subtraction, I want to do the inverse operation of subtraction, which is addition. So I would add 5 to both sides, and that cancels out this 5 on this side. And then b would be equal to 16 plus 5, which is 21. And I could also remember I could substitute in 21 for b, and I could solve that problem to make sure that I get that answer. So 21 minus 5, I would borrow from the 2, make it a 1, and make this one into an 11. So I'd borrow 10. Then 11 minus 5 is 6, and then 1 minus 0 is 1. So I know that I got that problem right, because when I subtract, I get 16. So 21 minus 5 is 16. So I know that b is equal to 21. All right, this next one is a subtraction one, but you have to be careful with this one because you also have a negative number. So x minus 11 equals negative 6. So since I have subtraction, I would add 11 to both sides. So now I'm going to add 11 to negative 6. And remember, when you're adding integers, you really are subtracting, and then you keep the sign of the bigger number. So negative 6 plus 11, if I subtract 11 minus 6, I get 5. And then the 11 has the larger absolute value. And so I would keep it positive because 11 is positive. And then I could even check and see, is 5 minus 11 negative 6? So if you think about 5 minus 11, you're starting with a smaller number and you're subtracting a larger number. And so it's going to go into the negative. So if you think about a number line, if you start at 5, so 1, 2, 3, 4, 5. If you start at 5 and then you go down 11 spaces, so let me put in some negatives here so you can see this. Negative 3, negative 4, negative 5, negative 6. So if I start with a positive 5, and then I subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I get negative 6. So another way to think about that is you could just subtract these two numbers, 11 minus 5, and you do get 6. But then remember, your answer is negative because you're starting with a smaller number and subtracting a larger number from it. All right, and that was just to check your answer. So really all we did on this one, though, is we added 11 to both sides since it was subtraction. All right, the next one, we have addition. And so to undo addition, we could subtract. And this one's written a little differently, but remember, because of the commutative property, you can have 13 plus k, or this could also be written like this, k plus 13. So don't let a problem like that confuse you. It can be written either way. So if you have addition, I would do subtraction for my inverse operation. And I would be left with k equals 48 minus 13. So 8 minus 3 is 5, and 4 minus 1 is 3. So k would be 35. And then the last one, we have addition again. So I would subtract. So since we're adding 17 to w, to get w by itself, we would subtract 17. So negative 5 minus 17. When I have a negative number and I'm subtracting another number, or a positive number, what you really want to do is add those two and then keep it negative. So sometimes you might remember that we would do keep, change, opposite. So when we add two negative numbers, remember you actually add them, but your answer stays negative. So 5 plus 17 would be 22, but remember it would really be negative 22 because we're adding the same sign. They're both negative. All right, so now you should hopefully know how to solve one-step equations with addition and subtraction.